Is it showing up?
Yep.
All right. Sweet.
So there's no link to follow for this week's presentation?
No,
Is that right?
I was having technical difficulties with Amazon Web Services.
Okay.
So you're gonna just hear my lovely voice.
I'm swooning over here.
All right. I think we got everyone back, so we can go ahead and get started. So I guess welcome everybody. Thank you for joining us for part 2 of Python for Beginners. We got Blake Lohn-Wiley here again to give us the second half of the presentation. As he said, we won't have a link for this part. He'll give you guys more details about that, but we're going to show you guys some applications of Python, and then also how you can use Python in your daily lives and in your applications. So with that, I will go ahead and turn it over to Blake and see what he's got for us.
So unfortunately, due to technical difficulties, the Amazon web server is not available. And as a result, this will not be as interactive and hands-on as prior. With that being said, let's get started. So just a refresher, this is Python for Beginners for part 2. This is a little bit more about myself, just as a refresher. There's no need to read about this because you all have stuck around for the last one. And again, thank you for showing up. So just a quick review for those that were there. The previous presentation covered a 50,000 foot view of Python. And what that entailed was the data types, data structures, functions, classes, iteration, file input, output, operators, and much more. This one will focus on how those concepts play into what's called Python packages and modules. This is still the outline for the presentation, except with the exception that there will not be the interactive part. So just bear with me. The goals of this presentation are that afterwards you should be able to understand and recognize the following. Just very basic concepts, understanding what packages and modules are, how to import them, how to see the contents of what's inside, importing a data set, cleaning and structuring a data set, visualizing your data, building a data set from a website, detecting patterns within your data set, and then grasping the versatility of Python. Correct. There was going to be a website scraping component, but that again, that's not viable because of the Amazon Web Services instance issue. So what are packages and modules? What are they? What are their contents and why are they important? So Python packages it's a collection of modules in a directory that gives that package hierarchy. They are important because packages are the foundation for Python's versatility. They have attributed to a lot of additional versatility within Python itself, except being able to handle various data types, being able to read in CSV files, TSV files. CSV files are comma-separated files. TSV files are tab-separated files. There are also the ability to read in SQL tables, Microsoft Excel, notebooks, spreadsheets. You can read HTML directly in. So these are the main data and visualization packages used primarily within most of the scientific domain. You have NumPy, SciPy, Pandas, Matplotlib, Bokeh, sklearn, URL open, RE, beautiful soup. Those last three are specifically utilized for web scraping. And if you provide a URL to those packages after importing their contents, it allows you to manipulate all of the HTML tags, create lists, and extract them into dictionaries. It's very, very, very versatile. So for those of you that don't know, NumPy, it's a library for Python programming language. It allows you to handle large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on those arrays. SciPy contains modules for optimization, linear algebra, integration, interpolation, special functions, Fourier fast transforms, signals, image processing, ordinary differential equation solvers, and other tasks common in science and engineering. Panda is a fast, flexible, and expressive data structure designed to make working with relational or labeled data both easy and intuitive. I can't speak right now. Matplotlib is a plotting library for Python programming and its numerical mathematical extensions, such as NumPy, SciPy. It also provides an object-oriented API advanced programming interface for embedding plots into applications using general-purpose GUIs. Graphical user interface is toolkits like Tinker, Qt, GTQ. Also allows you to plot within Juniper Notebook. Boku is another visualization library that targets more for web browsers, presentations. Its approach to plotting is different than that of Matplotlib. It uses more of a HTML-based D3.js. D3 is a visualization software written in JavaScript that's highly used in most interactive websites that utilize HTML5, things along those lines. And then sklearn is the primary package that is used for machine learning and deep learning algorithms. It makes importing those therefore above mentioned 6 packages make importing data much easier and much more user intuitive. Back when about 7 years ago, started using Python and R, a lot of the functionality that these packages provide was not available. So we had to write what would be maybe about 500 lines of code to achieve what these packages provide. You can now take those 500 lines of code down to about 20. These packages are put out by Continuum Analytics. They are used widely across every industry. I guarantee you, if you talked to anybody from Facebook, Google, any of the national labs, NASA, they are very well aware of these packages and their utilization, and they're widely adopted. So moving on. So this was so what I had designed was I had a Juniper notebook that was similar to last time that showed you how to import packages. Specifically, this one would be plotting with matplotlib, and it would show you how to import data into matplotlib. It would show you how to create a plot, change figures, label axes. It would also show you more of the interesting routines within matplotlib, and those would be pyplot. Pyplot has defined routines such as scatter plots, 3-dimensional plots, contour plots. So the data that matplotlib can take can be in the form of arrays or lists, and again, then that can be accredited to the package NumPy. and a mixture of SciPy. Matplotlib is often used to visualize analysis or calculations. That's why the first step for you in order to understand how Matplotlib works is understanding the different aspects of a figure. So the component of a plot is you have your figure, your title, your axes, your colors, your legends, and your subplots. If you look at the second figure there that has the horizontal and vertical bar graphs, that would then utilize a subplot. And so this all stems, so the basic concept for a plot is designed around the idea of a a figure is, if you remember back to the first webinar where I discussed objects and classes, a figure is a object that's created when you copy over all of the information from the package matplotlib, and then it allows you to access the attributes of that figure. One of the very unique features of matplotlib is, if you, let's say that for a mental exercise, we called our plot PLT. It is very easy to set the title for that specific figure by just referencing plt.title, and then you would enter a string, and that string would then be displayed as the title. And to put a title for the x-axis, it's the function call would be plt.xlabel, plt.ylabel. It's very intuitive in terms of its ability to represent data very easily. You can do vertical bar plots, horizontal bar plots, contour plots. These are just a few examples listed here above, but you can also do heat maps, three-dimensional plots, vector field plots, and it's again, like I said, it's very intuitive with how these are accomplished. One of the great things about matplotlib is its ability that it has these, what I would say, plotting routines, where you have access to, when you import that package, to generate a scatter plot, all you would have to type is plot.scatter, and then the input parameters would be that of your x and y axis, the data that's represented as a coordinate pair. And then the data can be passed as either a list or an array. It's very simple to just say, if you wanted to do a linear line plot where your coordinates were 1, 1, 2, 2, 3, 3, 4, 4, Python has a built-in feature where you can say the function range, and the input parameters for range are your starting value and your ending value. So let's say that we just wanted to plot a linear line from 0 to 9. All we would do is we would define a variable, again, remembering back to the first series. It would be x equals range 0, 9 in parentheses. Then y would equal the same, where it would be y equals range parenthesis 0, 9 in parentheses. And then all you would have to do is just say, after calling the object PLT, we would say plt.scatter, and then the two variables that we previously just defined as x and y, we would just pass them on to that, and then matplotlib would then return a scatter plot or a linear function of those data points plotted. And it's the same way, and the great thing about it, though, is it's the same way for your vertical bar plots, your horizontal bar plots, your contour plots, your three-dimensional plots, your vector plots. Obviously, it's not the same input parameters for each, but it's very similar in the construction and how it itself accepts these parameters. And Another great thing about matplotlib is its ability to easily just delete axes, adding legends, like I described earlier, setting plots and axes titles, also additionally fixing the layout. If you needed to, like, let's say if you look at that second example of the scatter plot with the label, and if you would imagine that that legend, I'm sorry, not label, but legend was not showing up correctly, you can redefine it by, okay. You can redefine it and then reposition it over and then re-enter the commands and then it would then show up. And another good thing is that about matplotlib is the quality of the plots generated. It allows you to save the plot not only as an image file, but as a PDF as well. And one of the most important things that I will continually say is that regardless, and this stands for any sort of file input output, when you have a plot and you want to save it, make sure that in addition to saving it, you close it, because otherwise some funny things can happen. It may not save properly. It may not work as designed. And if you have a presentation and you are super stoked and spent 10 hours on this one figure, and it encompasses everything and it just articulates and communicates the message that you're trying to get across, make sure that you close it. And previous or after you save it. So this next part is designed primarily for if you have a data set, how do you go about ensuring that it's of the utmost quality, that there aren't any missing fields, ways in which you can explore the data. So you have your primary function within the pandas package is your read_CSV function. In addition to that, you also have read JSON, HTML, Excel, SQL, and there's consistency in terms of their input parameters or the inputs required for these functions to import the data. The input parameters consist of the location of the file that you're trying to input, how that data is separated. For example, if you use the read_CV function, your first input parameter would be the location of the file, and then your second input parameter would be how is that file or data delimited, or how is it a space between each column, is it a comma between each column, is it a tab? And then the third input parameter is whether or not the first line of the file contains the headers or the names of the columns. So one of the amazing things that Python does is allows us to do exploratory data analysis. EDA is very similar to that of data mining. They're closely related, but the two differences are that in EDA, you typically explore and compare many different variables with a variety of techniques to search and find systematic patterns. Data mining, on the other hand, is concerned with extracting patterns from the data. Those patterns provide insight into relationships between variables that might be used to improve the increase the predictiveness of that model that you're using. They both share in common that there is no prior knowledge or expectations from the importing of the data set. Data mine is relatively concerned with identifying specific relations between the involved variables. As a result, data mining accepts a black box approach to data exploration and doesn't only use techniques that are also used in EDA, but also techniques such as neural networks to generate valid predictions, but don't identify the specific nature of the relationships between the variables on which the predictions are based. So another thing that with these that comes in natural to these is the ability to explore your data. To essentially, if you import a data set to in a Python package or using the pandas package, there's a function that's called describe, and what describe does is it allows you to peek inside the data, and what it displays to you is the number of elements, the number of unique elements, the means for the various values, the standard deviation, what the minimum values are, the maximum values are, and the quantiles of the data. What this does is it shows you the distribution of your data. It also shows you, is your data categorical? Is it numerical? Is it binary? In doing so, it's important that you look at your data first before you start trying to apply different techniques to it, because otherwise you're not going to understand what the algorithms themselves or what the functions are returning to you. Another nice function, it's called the head function, and what that does is exactly as it sounds. It returns to you the first 5 lines of the data set, and then the tell function returns to you the last 5 lines or last 5 rows of your data set, otherwise if not specified. You could also define and say, okay, I want to look at the first 20 lines, and then your first input parameter would just be 20. Same thing with the tail function. If you wanted to look at the last 20 rows of the data set, you would just say tail, 20. Now, the nice thing is if we remember back to the read_CSV file, let's say that our data that we're going to be working with is a comma separated file, and we set that as, we'll set it equal to CSV_data file equals read_CSV, and then those input parameters. When we create that object, the CSV data file, we can then utilize the head and tell functions by just simply typing in the name of the object we've defined. So in this case, it would be CSV_dataset. And we could then do period head, and then that would immediately go and extract just if we don't define how many lines we want or rows, it will just bring back the first 5 rows. That's one of the nice things about Python, is because it's an object-oriented programming language, we don't have to worry about ourselves writing a function to go and do this. Because when you import packages, again, you're making available to you in your current workspace all of the functions that are listed in that package. And again, because it's object-oriented, any attribute that is associated with a class becomes directly accessible by referring to it as a attribute. Continuing on. So some of the challenges of your data when you're uncertain of what it is, or if it's given to you, and let's say your mentor or your advisor hands you this data set and just basically gives it to you, and it's just like, could you just make something of this? You want to make sure and ensure that aren't any missing values. If there are missing values, you want to fill those in. If you, again, another way to again, EDA or exploratory data analysis is checking to see that your data set has missing value or has no missing values. And if it does have missing values, you fill them in or you eliminate them completely from the data set. Another way to see if these missing values are going to affect the validity of the results or of your interpretation of the data, one methodology you can use is interpolation. Another way is to do a distribution of the data, see how it would basically think about it as a probability density function, where you're looking at the range of where the data consists. So if your greatest value, if your smallest value is -200 and your greatest value is 1,000, looking at the distribution of the data allows you to see primarily where most of the features concentrate in. If, for example, you have outliers, let's say that our data ranges, going back to the example of importing your CSV file, let's say that our smallest value is -50 and our greatest value is 1,000. And if we plot it and we look at the distribution of all the data points and we see that they all are within -25 to 50, then and we notice that we have, you know, a couple outliers, a couple points over near close to -50, and then 2 or 3 towards 1,000. We can then focus in on just the area where most of the data is concentrated. Outliers can have a negative impact on the interpretation of the data when it comes to if you're trying to fit it or cluster it or factor it in any other various ways. Another part of exploratory data analysis is feature engineering. Feature engineering is a way to increase the predictive power of learning algorithms by creating features from raw data that help the machine learning algorithms process. You'll do this by creating additional relevant features from the existing raw features in the data. Feature engineering is something that will cost a lot of time to do, and it's not always clear what you can do with the raw data, so you can help with the predictive power of the data. But and that's where feature selection comes in and is a way to ensure that, let's say that you already know what your features are, and you don't need to engineer them or you don't need to generate them. Feature selection it's a suite of available algorithms built into the NumPy, SciPy, Pandas, and sklearn Python packages that allow you to extract more relevant information from the data itself. And then in doing so, thus then increases the accuracy of when you run these machine learning algorithms on the data itself. Another good way, and the feature engineering and the feature selection play directly into pattern detection, and that's really the bread and butter with exploratory data analysis. Is all the previous slides all aim towards getting to helping you detect patterns within the data itself. Think about it as a process. And you first start with ingesting your data, importing it. You then you then do some very basic exploratory analysis of it, to see how the distribution of the data plays out. How are there any missing values, XYZ? Then you go to feature selection, feature engineering, and then those feed directly into pattern detection. Pattern detection is usually done through some sort of visualization. The two primary packages that I work with are Matplotlib and Boku. And then and one of the direct examples was going to be correlation identification. And what that does is it looks at, so let's say that if we go back to our CSV data set, and we have, and in that file, we have 50 columns, and each column has a different name associated with it. So there's no duplicates. And we have no idea if any of the variables or column names are related to one another. Correlation identification would allow you to visually plot the results and see if, in fact, variables 1 and 2 are directly related. And in doing so, any detection of correlation between variables inevitably affects the output of your interpretation of the data set, your takeaway. So the takeaways from this presentation are that you understand what packages are, what modules are, how to import a data set using those packages, cleaning and structuring a data set, visualizing your data set, and then detecting patterns within the data set, and then grasping the versatility of Python. Any questions?
All right. Well, thank you very much, Blake. Does anyone have any questions? You can feel free to unmute your microphone and go ahead and ask. Yes, no, maybe so.
I will be sending out an email for the interactive portion that will reinforce the ideas that were covered. And they will be housed within a Python script that you yourself can execute. Or I'll figure out a way that you don't need to install Python and you can run by that. And then again, this is recorded and it will be available on YouTube. So you can do it step by step.
Yes, we'll have all our resources available to you guys. If you guys do have any questions, feel free to reach out to us at any point. We'll do our best to answer them. Otherwise, we'll get you guys out of here. There is a feedback form link that I put in the chat. We would greatly appreciate it if you guys would fill that out. It asks what you guys thought about this webinar, and then also if there's anything that you guys are interested in learning about in a future webinar. So if you guys could fill that out, we'd appreciate it. And then also just be on the lookout for emails about future webinars and also anything else going on with the Sustainable Horizons Institute. Alrighty, and again, thank you, Blake, and thank you everyone for joining us.
Thank you very much.